All right. So Claude goes to school by the bus. Did you draw a bus on the board? That's okay. We don't have time. That's right. No, that's right. The probability that the bus is late is 0.1. If the bus is late, the probability Claude is late is 0.08. If the bus is not late, oh my gosh, I'm getting confused already. The probability Claude is late to school is 0.05. Okay, wait. The thing I have trouble with most in probability is like overthinking it. So let me make sure I got this right. Okay? So, probability the bus is late is 0.1. Does that matter if Claude's on it or not? No. That has nothing to do with him. Okay? But if he was going to ride the bus, then he would have a 0.1% probability he would be late. Right? Because if he was riding the bus, then he would be late. Is that right?
Yeah.
Right. So if he was riding the bus, okay, he had a 10% chance of being late. Okay. If the bus is late, the probability... Oh, I take it back. Look at that. Wait, how would that be? How could the bus be late, but he not be late? Wait, because look, it says that if the bus is late, the probability Claude is late to school is 0.08. How could that be?
He misses the bus too. It's late, so he misses it.
If it's late, they're both late.
Right? But that's even higher than this, right? So the probability that Claude is late, if the bus is late, the probability Claude is late is 0.08. What would happen there? What would make that happen? Why is it so much higher?
Different route.
Yeah, but we already have like a tenth. We have a tenth that the bus is late.
Wait, does it mean like late, like to his bus stop or at school?
No, it doesn't really say late to school. Look,
Oh, okay.
and we're assuming this means late to school too. I don't know. If the bus is not late, so if the bus is on time, the probability that Claude is late is this. It sounds like Claude has trouble getting to school on time, doesn't it? Because even if the bus is on time, he's not on time all the time. And if the bus is late, it looks like he uses that. It looks like he uses that as an excuse. I don't even know. So I know it's confusing. It's confusing. So calculate the probability that the bus is late and Claude is late. Okay. So I would do a tree diagram. Like that's the math and whatever. But let's talk about the bus and Claude. Oh, can you guys see that? So let's say late, right? Late. On time. On time. Okay? So Claude is late, bus is late. Okay? So what's the probability that the bus is late? 0.1. What's the probability if the bus is late, the probability that Claude is late is 0.08. So that would be both late, right? What's that? Would it? No. If the bus is not late, if the bus is late, the probability Claude is late is 0.08. If the bus is late, the probability Claude is late is 0.08. Hold on. What's that? Yeah, I know. I keep saying it wrong. I'm looking at my answer and getting it mixed up. Okay. Let's make a nice tree diagram. You could do this with us. How many of you guys got 0.08 for that answer anyway? Because it's right. Okay. Well, looks like a spaceship. Very beautiful. So we'll say this is the bus, and this is Claude. The bus could be late, or it could be on time. So 0.1, 0.9, we good? Okay. Help me fill out the rest of this. So it says if the bus is not late, so that's on time. the probability that Claude is late is 0.05. Where would that go? Would it go like the whole thing? Like the whole branch would be 0.05? Do you guys agree with that? You don't agree.
If the bus is not late, probably he's late to school.
This is why it's confusing, right? Oh man, it's confusing interpreting what it's saying and putting on a tree diagram. So I got some people that say like the 0.05 is the whole branch. Some people think the 0.05 is just this part. Which is it? And how do we know? It's this part? Why? The reason why, because if you read it carefully, it says if the bus is late, the probability Claude is late to school is 0.05. It doesn't say if the bus is late and Claude is late. And would be both. Do you see what I mean? Does that make sense, Alexis? That's why the 0.05 goes right here. So then, to get like the whole thing, we'd multiply those two together, right? Okay, and so that means this would be 0.95. Is that right? Yeah? Do you agree? Are you asleep, Mario? I know your eyes are open, but are you asleep? Alright. Okay. Do you guys agree with this? Do you understand why I believe it goes right there? Do you? Yeah, or no? Yeah? Because it doesn't say, it's not the whole branch because it doesn't say the bus and he's late. It's like, if the bus is late, this is probably he's late. Okay, if the bus is late, the probability he's late is 0.08. Okay, so where would that 0.08 go? Here or here? At the end? Or right here?
Right there.
Right there? Why?
Yeah, so you can make them see
Because of the same reason?
them.
Yeah. And so this would be 0.2. Is that true? Okay. Okay. You're confident? You're good? Okay. So, so part 1 says calculate the probability that the bus is late and Claude is late to school. You see right here where it says and? That's like the whole branch. And these don't have the word and. Like in the descriptions, they don't have the word and, so it's just part. That make sense, Christina? Yeah? Okay. We're all good with that? Okay. You sure? Maybe you should make a note of that. And means the whole branch. No and means just part. Good to go? Okay. So anyway, calculate the probability that the bus is late and Claude is late. So that would be this whole branch because it says and. So this would be 0.8 times 0.1, which is, I don't know why I put it in parentheses right there. Oh, sorry about that. I thought you could see it. Is that okay? Yeah? Okay. Number 2 says calculate the probability that Claude is late to school. Oh.
0.8 plus 0.0.
Wait, so 0.8 plus what?
0.05.
Where did you get 0.05? Oh. Do you guys agree with that?
Yes.
You do? But wait, how can this happen? I don't agree with that. I don't think it's 0.08 plus 0.05.
No, 0.8 plus 0.5.
Oh, you guys say
Oh, you think it's this plus this?
Yeah.
I don't. because the bus plays a role.
So you have to multiply it?
This times this, plus that. Right, Isaac, or no, Isaac? Wait, hold on. So, this is one way he's late right here. The other way he's late is that the bus is on time and he's late. So, oh yeah, sorry, I said it wrong. So, the probability the bus is late and he's late is 0.08. The probability the bus is on time and he's late is something we haven't figured out yet.
So there's asking if Claude is late, not the bus and Claude.
Wait, what?
There's asking if Claude is late, not the bus and Claude.
That's true. That's true, but he has to take the bus to school. Because we're assuming, I mean, like this is the problem with this problem is it doesn't say he could walk, but we're assuming the only way he gets to school is by taking the bus. So he's taking the bus.
But
So the,
wait,
oh yeah.
if the bus is not late, he's still late. Like if he's missing the bus.
Right. So like the bus is on time. Well, the bus can be late and he can still be on time. Because think about it, when you get, this is what I was hoping you guys would say when I first asked the very first question. Your bus can be running late, you can still get to class on time. Because your bus gets here before school starts. You just have to skip breakfast or whatever. Right? Yeah? Isaac doesn't take the bus? No, he does. No. Do you know what I mean, Isaac? Yeah, so I'm sorry if I confused you the other day. I probably didn't draw a nice, pretty diagram like this, and I probably messed it up myself. And I probably wasn't thinking like that the bus is, he has to take the bus. It doesn't say it very clearly, but I think we have to assume he's taking the bus. Ay, Hector. Do you see why probability is confusing? It's all about the interpretation. The math itself is easy. It's the interpretation that's difficult. Yes, ma'am?
Would it be like that because like Claude is dependent on the bus to take him to
Yes,
school?
definitely. Claude depends on the bus. Okay, so there is another way he can be late, and that is if the bus is on time, but he's still like, I don't know what he's doing. I don't know what he's doing. So anyway, what would this be? It would be 0.9 times 0.05. What's that? 0.045. Do you guys agree? So the probability that Claude is late, just overall, there's two ways it could happen. And that's an or. Do you follow me? It's an or. Because he could be this way or this way. So you add them. Because it's an or. Ands you multiply, ors you add. So the probability he's late, there's two ways that could happen. That's the probability that the bus is late and Claude is late, or the probability the bus is on time and Claude is still late. So 0.08 plus 0.045, and that would be 1, 2, 5. Is that true? 0.125, which I think is 1/8. He's late a lot, in my opinion. Mario, did you get that? Isaac, if I confused you on that the other day, I'm very sorry. I should have been more careful drawing this out. Yeah. Okay. Are we good or not good? Yeah, what about Alexis? Is she good or not good? Alexis, do you see like the whole thing about what I'm talking about with the and the not the and? The not and is just talking about the piece, the and's talking about the whole thing. Okay? And if you were confused about that, like, I think where you would hopefully realize like the difference would be, you see how this says calculate the probability that the bus is late and Claude is late? Is different than this. If the bus is late, the probability Claude is late. They're different. You see what I mean? And this one's easier to see that it's talking about the whole branch, and that means that this one's just talking about the piece. Do you understand what I mean, Jesse? So even if you got confused when you're taking your test, hopefully the problems themselves can help you piece it together. Okay, last one. The school term is 56 days. How many days would you expect him to be late? Oh, expected value. Well, what do you got? What do you think? What's that? I hear like,
I heard 86 days.
oh, 56 days. It almost sounded like a horror movie, like a trailer, where you hear like this whispering in the background, and like something fades from black to like this murky red to like this weird green, and all of a sudden you see a scary face and you hear the whispering in the back. That's what it. Yeah. So anyway, hey, wait. How do you do this? What do you do, Ruby? That's exactly what you would do. Look, this is a probability he's late on one day. So you would just multiply that times 56. And you get 7. Is it 7? 7. So the probability these late, or what's, what do you expect? What's the expected value for him being late over a 56-day period? So you just do 56 times 0.125, and that is 7. And the reason I knew it was 7 is because I know that's 1/8. The reason I know that's 1/8 is just because I know stupid things that don't do me any good sometimes. 0.125 is 1/8. Okay, good? Yeah? Okay. Sebastian, you alright?
Yeah.
You sleepy? Yeah, me too. I'm Betty sleepy. Alright. Oh boy. Let's see here. Jack and Jill. Huh? So let's see here. Jack and Jill are rolling dice. 1 through 6. What's the probability Jack threw a 7? 0. It's impossible. Okay. What's the probability they both threw a 6? 136, because probability 1 would throw a 6 would be 1/6, then the other would be 1/6, so that'd be 1 over 36. Okay? Next one's tricky, that neither threw an even number. I don't think it would be 1/2. Are there? Well, maybe it would be. Huh. So let's see. There's 2, 4, and 6. Okay, that is 1/2, right? There's 2, 4, and 6, so 1/4. 1/2 times 1/2. Okay. Are we good? All right. And then Jack threw a number exactly 4 more than Jill. Oh boy. How many ways could that happen? Like what numbers would it have to be? So it'd have to be a 1 and a 5, or a 2 and a 6?
Yeah.
So let's see. Oh, there's no room to write right here. So it'd be a 1 and a 5, or a 2 and a 6, right? Okay. How many ways can, let's see here. A 1 and a 5, or a 2 and a 6. And Jack threw exactly 4 more than Jill. So how do you set this up? Why 2 6 times 2 6? Wait a minute. So the probability that, here I need some scratch paper. The probability that Jack threw a 5, let's talk about Jack and Jill. So we're talking about rolling a 5 and a 1, right? What's the probability he rolled a 5? 1/6. And what's the probability? 1/6. So what's the probability that happened? 136. And then 2 over 6. Sorry, 1 over 6. Because if, like, he could roll, oh, the other way, 6 and 2, right? And so that would be, yeah or no? Yeah or no? Isaac? No? Why? You don't know why. Wait a minute. Like, this would be the probability that Jack threw a 6 and Jill threw a 2. Probability they both happen together would be that. Correct? Or, the other way it could happen, that he rolled 4 more, would be he threw a 5 and she threw a 1. Is that right? So then what? Add them together. So 2 out of 36 or 1 out of 18. Are you guys in agreement or are you disagreeing? Do you agree or disagree? You agree? Are you sure, Christina? Okay. Okay, let's do number 2. Let's see. What's unbiased mean? Yeah, so it's fair. Like, you won't have a greater probability of getting one more than the other. Okay, one spinner is numbered 1 through 6. The other's from 1 through 3. The scores are multiplied. Okay, find the probability the outcome is even. Let's see, there's how many totals? 18, right? So it's going to be something over 18. So, 1, 2, let's see, 3, 4, 5, 6, 7, 8, 9, 12. Yeah? Easy? Okay. Mia, no questions. Okay. Find the probability that it's, when the outcome is even, find the probability is greater than 11. Well, there's 12 even. Just found that in the previous problem. Okay, greater than 11. 1, 2, 3. You guys in agreement or disagreement? Yeah? Did you have a problem like this on your test last Friday? Same exact one? No? But it had the same answers? Yeah. And some people put 3 out of 18 right here. It made me a sad panda. Yeah. Because, yeah. Whoa. Whoa. What was that?
My journal's falling apart.
Weird. Math overload in the journal, huh? Okay. Adam writes his name on 4 cards, and Daniel writes his name on 6 cards. Oh, 4 red and 6 white. And I guess this is supposed to be red, and that's supposed to be white. Yeah.
For like the one we just did 2B.
Yeah.
Why is it 3 over 12?
Well, because there's 12 even cards. Right? You're looking at me all weird. Look, when the outcome is even. Right? There's 12 of them that are not even cards. There's 12 even outcomes. There's 12 even ones. We just counted them. That's how we got this 12. Right? Even ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the outcome's even. Right? Okay. That's what it says right here in English. Right? It says, now find the probability that the outcome is greater than 11. Well, that's 12, 12, or 18. That's it. There's 3 ways that could be more than 11. Yeah. Thank you for asking. All right. Adam writes his name on the red, Daniel on the white. Okay. Part A says, one of the 10 cards is chosen at random. Find the probability that the card is a D. So that's just 2 out of how many? What is it? 2 out of 10. Good Mia or bad Mia? Okay, Mia, what about number 2? The card is red. Wait, the card is red. The card is red. The card is red. Wait, does yours say this?
No.
I have a feeling I adjusted this. What's yours number 2 say?
The card is red.
Just the probability. Oh, this was supposed to be the next question, huh?
Yeah.
Oh, yeah. I remember I fixed this. I didn't make copies of this one. Okay. So the card is red. What's the probability the card is red? 4 out of 10 for shizzle. Okay, for the next one, I apologize. It says the card is red or letter is D. So that's just adding these 2 together, isn't it?
Yes.
Right? So is it 6 out of 10? 6 out of 10. Are we good? Mia, you were like frowning until I said we were good, and then you shook your head yes. Which is true? You got it? Okay. Because like this is the probability it's a D, and this is the probability it's red, so you add them together. Okay, so this part is 4 out of 10. Next question. Yeah, I know. It's because of how it's written. Do you guys have this one? Yeah? What's the difference between this and that? The word and. What's that mean you do? So then it's going to be 8 out of 100?
What?
Is it?
Oh, yeah.
Or no?
Yeah.
I don't know. I'm telling you. I'm asking.
What would you reduce it? It would be like 2 out of 25, yes?
I don't know. Is it?
Yes.
You guys think that's true? Because I don't think that's right. I don't believe that's right.
Why not?
You know why I don't think that's right? Because I didn't do any math. I just did a shortcut and I just multiplied, which means I'm probably wrong. I did a RAM, right? A random act of math. I don't believe that's right. I do not believe that's right.
4 times 2.
All right, stay with us here. Stay with us here. Stay with us here, Sophia. Come on, stay with us here. Let's do this. Check this out. The card is red and it's a D. How many red Ds are there? 1. And how many cards are there? 1/10. You're picking 1 card, not 2. This would be picking 2 cards. This is picking 2 cards right here. This is picking 1 card. This is picking 2 cards. What's the probability I pick a card and it's red and I replace it and then I pick another card and it's a D? That's what this is. This is, you pick a card, it's red and it's a D. It's 1 card. It's 1/10. Oh yeah, tricky, tricky. You can't just see the letter and go, I'm going to multiply stuff. You gotta be careful. Math is like dating. You don't want to rush in, make a stupid mistake, get your feelings hurt.
So you're
Okay. Onward and upward. Next one. What? What's your question?
like, does it mean like it means both the red card and has letter D, or?
Yeah, you're picking a card and it is red and it is a letter D. It's like if you have a deck of cards, what's the probability you pick the ace of spades? There's only one of them. Okay. Hector, where's your paper? Oh. Hector, how many have you gotten right on this page so far? How many have you missed? 1. Which one?
1D.
This one.
Yeah.
Okay. All right. Let's do this one. Adam chooses a card. This one causes the most trouble on all of this. So this. I'm glad we were going over this. I didn't think it was going to take as long as it is, but I think it's a good use of our time because it seems like we got some confusion, right, Alexis? Yeah, that's okay. All right. So Alexis says Adam chooses a card at random, and then Daniel chooses a card at random. And you see it says of the remaining 9. Does that mean does that mean Adam replaces it or keeps it? So no replacement. Big deal. You don't see the word replacement or not replacement. Do you see what I mean? So you'd have to you have to really understand what it's saying. It's really easy to understand what it's saying if you read it, but so often people don't read stuff, right, Karima? Yeah. Karima, then it says find the probability that the letters on the cards are both D. So let's see here. Adam's first. There's 2 D's out of 10. Then there's 9 left and only, so would you guys agree it's 2 out of 90? Yeah? You sure? Okay. Let's see here. They're both A. There's 1, 2, 3 A's. Is that right? So 3 out of 10 times 2 out of 9. 6 out of 90. Would you guys agree with that? Yeah? Okay. The probability that they are the same. This is where it gets tricky. Would this be an or an and? And an and.
What?
It's an and an or, huh? Because look.
Both answers be accepted, or was it just one or the other?
Wait, no, watch. They're the same, right? These are ands, correct? And there's 2 ways for it to happen, so it's this plus this. So it's an and an or.
You just added enough or.
Right. But the way I got this was with an and.
You have to add to get
You see? I know, it's weird, right? Whoa. Okay. The probability that they're different. If this is the probability that they're the same, then the probability they're different would be, right? Do you agree? I agree with you? I always agree with you. That's why you're my favorite student. Okay, Little Miss Sunshine. Who's got questions on this one? The last one? Well, because look, they're either the same or they're different, right? And all the probabilities have to add up to 1. So if this is 8 out of 90, that has to be 82 out of 90, because they have to add up to 1. Bless you. Why is it rude to say bless you before you sneeze? Because then it makes you not sneeze? Yeah. I'm rude like that. Okay. If I remember correctly, nobody got part C right last year. Oh, I took it off. You guys are so lucky. I took it off.
Okay, just say yes and go.
All right. So, let's see here. The tree diagram. Here's the tree diagram. Shows a testing procedure on calculators taken from a large batch. Each calculator is chosen at random. The probability that it's faulty is 1 out of 20. I think I would find a new manufacturer if 1 out of every 20 is bad. That's crappy. Okay? Write down the values of P and Q on the diagram. So here's P, there's Q, there's P, there's Q. That's weird. So we got 108. Oh, this is faulty, right? And this is not faulty. So this is 1 out of 20, and this would be 19 out of 20. Would you agree with that?
Yeah.
So would this be 1 out of 20, and this would be 19 out of 20? Because faulty, not faulty. Would you agree with that? Yeah?
Yeah.
Okay. I'm going to do extra. I'm going to go ahead and put them all right here. Because, I don't know. Because it makes me happy because I fill out the whole thing and I have a feeling I'm going to need it. Okay. Part B says 2 calculators are chosen at random. Calculate the probability that they are both faulty. Okay. 2 calculators chosen at random. Okay, so the first and the second. What's the probability they're both faulty? How can we figure that out? It'd be this times this. So 1 out of 400? Do you guys agree? Yeah? Okay. What's the probability exactly 1 is faulty? This is where people get in trouble too. So exactly 1 is faulty. This is an and an or. Again, Karima. Because there's 2 ways exactly 1 could be faulty. Either the first one's faulty and the second one is not. Do you understand what I mean? Or the first one is not. Sorry, and the second one is. So look, you got calculator 1, calculator 2, calculator 1, calculator 2. There's 2 ways this could happen. Faulty, not faulty. Not faulty, faulty. Because it says exactly 1. It is faulty. Yes, ma'am.
You know how there's 2 different options?
Yeah.
They equal different things. Which one do you choose?
Well, wait a minute. Well, it depends on what you're doing. Like here, it's or. So you would just add them. Because there's 2 ways you can have 1 faulty calculator. So this way, faulty and not would be, would you tell me if I'm right? Faulty and not would be faulty and not. So it would be this times this. Would you agree? So 19 out of 400. Or, which is plus, not faulty and then faulty. Oh wait, sorry, not faulty and then faulty. So, same thing, right? 19 out of 400. So the answer would be 38 over 4%. How many of you guys got that right? Dang, not very many. Okay. Do you see how there's both conditions and you have to be careful you got both conditions? Okay. I know you don't have part C, but part C is muy importante. Here's what it says. It says, if exactly one of the 2 calculators Oh, I shouldn't talk as fast as Kareem. If exactly one of the two calculators tested is faulty, then a third calculator is tested at random. So exactly one of two is this, correct? Okay. And then we look at the third row. So then we look over here. Okay. Calculate the probability that exactly one of the first two is faulty and the third is also faulty. Okay, well, first of all, like the first part, right? Exactly one of the first two is faulty is this number. Would you agree? Okay. And means the third is faulty. So what's the probability the third is faulty? 1 out of 20. So 38 out of 8,000. I don't know. Probably because it was my first year teaching it, and I didn't do as good of a job. Maybe. I don't know.
It's not 1 over 400 since it's 2.
No, there's
The top one and
because you can't follow it exactly. Like we have this first condition covered, right? And so we already have one of the two first ones faulty. So 1 of 2 is faulty, and then the next one could be faulty or non-faulty, and so it's 1 out of 20 or 19 out of 20, like that. So it's kind of a new tree diagram. Yeah. Okay.